Hello everyone, January 13th. Alright, let's do this. Minimum number of, I might have done this before. Oh, maybe not. Minimum number of steps to make two strings anagram. You're given two strings. In one step, you can choose any letter T and then replace it with another character. Return the minimum number of steps to make T an anagram of S. An anagram, yeah. So we need a counter for S and replace the first A in T with B. So, okay. Yeah, so I think what we need to do is just to count the difference in the counter. So we get a counter for this and get a counter for this, and for each letter we just find the difference. Because it does say you can change any letter in T and replace it with another letter, right? So if there's a difference, oh, hold on a second, it's not, because it's not just a change, right? So like in this case, we have S is B is 2, A is 1, right? On the T, we have A is 2 and B is 1, right? So by this, you say, okay, B needs to change. I need to add 1B. I need to reduce 1A. Now, once you come out, when you make changes, something will get decreased and something gets increased, right? So you need to find out which ones can be reduced, which means as we go through from A to Z, anything that's bigger on the T side can be moved, right? Anything bigger on the T side can be moved. In fact, that's all we need to do, right? And they say the length is the same, so they can always make the change, which means the minimum length is just how many, because if I have more of a letter on the T side, and those extra letters cannot exist, right? Those extra letters cannot exist. That means those extra letters needs to be changed. So that's the answer. Because anything additional needs to be changed no matter what. But exactly what they change it into, that's not of my concern. That's not of my concern. In this case, okay, you have a T, we have a C, all right, we have an E. T, C, E, and then we have 1, 2, 3, 4, 5, the rest. Okay. I think that's correct. The journey of configuring it still continues. That should be 13 today, right? Should go over this one. Yeah, and keep Pythoning. Keep practicing. Interview is coming. And this problem needs to be solved. Come on. I don't know what it is doing that it takes so long. So basically what we want to do here is, we're doing the counter. Say from, I remember it can automatically fill this, right? So SC, I don't know, counter. I don't know which one we would go. No, I don't want typing. Coroutine. coroutine. S. Wait. Really? I never defined counter. That is... Wait, hold on. Is it... Okay. No signature help available. Alright. Collections. Port. That's kind of stupid, right? And then if I go here, Control K. Still no help. Hold a second. How do I get signature? Open brace. That's auto completion. Yeah, I have no idea what it's supposed to have. Hold on, local counter. Oh, counter class. Interesting. That's not what I had expected. I thought it will give me a more expected value. Oh yeah, this is good. DP. Shoot. What is to scroll up and down? I remember it's not Control J, it's Control F? Oh, F. F and what? Control F and it's not. Oh, D. F and D. Oh, okay. F and D. Got it. TC is we're gonna counter again. Alright, and then T. And for rest equal to 0 and for I range. Can I see in I think string? Oh, I'm not sure. I think say from string. Let's go lower, upper, lowercase. Let's go lowercase. Rest plus equal to TC C minus SC C. But I need to go maximum of 0 in this. I know I return rest. What do you think? I think it might be right to yank this. Yep, I think so. Well, it's not bad. Not bad at all. Oh, and avoid autocomplete when in comment. It says it's merged, completed. I'm using this one, right? I'm not even sure. Okay, now do this. Enabled equals function. Look good to me. I have no idea. I need to try. Let's see what other people say. 2 years ago. I haven't tried the other one. This one. I'll research. Oh my god, another window open. Ha. Alright, this one is... Oh shoot. Thirteen 1347. The essence. The only, right? The only... Oh, I didn't even realize. Calculate. The only letters allowed to change is the extra ones in T that do not exist in S. Thus, the problem is equivalent to counting the number of extra letters in T. I guess that's it. I'll take a look at hash map. Yep, that's that. Oh, nice. You can do that. Yeah. I guess you can. I saw him. I was not able to get my Walmart.
The tofu?
There's no tofu for me. Zero, nada. So I put a request for tomorrow. So I'll go tomorrow, 9 to 10. Alright. Majority voting. Yeah, I know this algorithm. I used it before. I don't remember. Oh. Majority item. If n equals majority, count plus plus. Else count minus minus. If count is 0, the current one is majority. Huh. Majority count. Oh, they find the majority first. Then they count the majority. Then they go from front to back and then see if the count is good. What did you do? I think I countered it. Right? I think I countered it. Yeah, I use a map. Yeah, a map would take more time because of the map. So in their case, they run. Oh, but you do avoid. Okay, you do avoid this. That is a good point. So what's the counting? So you just keep count, right? And every time something is not the current majority, then you swap. If it is, you keep count. If not, you swap. So if you have some majority, then at the end, the count will be positive. Whenever it's not, you swap to something else. Oh, good method for majority count. You know what? Let's do this in Java, because this is already in Java. When was this? 09, and it's 2780. Yep, here we go. I don't have Java LSP. Oh, I think I was supposed to get it long time ago, but never does. I said I'm practicing, but it's fun. Just go back to Java for just a little bit, right? Just a little bit. Let's do this. Okay, so this is what do we call it? Using oh, what's the name? Boyer more. Boyer more algo to find the majority item without using a hash map. Okay, so we're gonna do majority, and yeah, the first step is to find the majority. So for int, and also we need a count. Okay, int count. Okay, so we say int n of nums, right? if count is equal to 0, right? If count is equal to 0, oh, I do have to initialize it. Okay, if count is equal to 0, then majority. Ay, ay, ay. Ay, ay, ay. You're gonna become super strong. And then count will become 1, right? Else, if majority is equal to n, right? If majority is equal to n, then we say count plus plus, right? And else we say count minus minus. So this is to find, okay, it just requires me to define it. It's okay. So this is to find the majority, and then we need to count majority. So I reset count equal to 0, right? And what do I need that in the count? So again, for int n to nums, we say count equal to n equal to majority, right? Majority, if it is, say count plus 1, otherwise we still remain count, okay? And then we're gonna go from start to end for int I equal to 0, I smaller than nums, dot length, no, dot size. We have to count again. Oh wow, after 3 rounds of counting, right? If nums I, no, dot get I equal to majority. If that's the case, then count plus plus. Yeah, we can do this inside. Hold on. Alright, and now we say if count. So what do we want? We want to see if it's majority on the left hand side and a majority on the right hand side. Okay. Oh, I cannot use the same count. Damn. So count, and we can call this L count. Okay, let's call it L count. If L count, oh, I need to define it. All right, if L count is times 2 is larger than I plus 1, that's the ones on the left, and count minus L count times 2 is larger than on the right hand side, which is nums dot size minus I minus 1, I think, right? Yeah. So if these two satisfies then we'll return I immediately. Otherwise, we keep going until the end, we'll return -1. All right, let's try this one. Yank it. Oh, I don't think this one works. Nope. This is not. See, that's the thing. Like, you get familiarized with one way, one text editor, and you go for the other one, and you forget how things go. Yep, that looks good. Let me just double say that. So first, this is Boyer more, right? Find the majority item, and then we say count the majority item, and the last one, find first index. Oh, look at the speed improvement. Since we avoid using a hash map, the speed improvement is significant. That's pretty good. So what we're gonna do is just do it here. Okay. All right, this is good. And we can turn off this. I don't want to do this. I might want to do this. 26 minutes in. Oh, I forgot about this one already. This I need to reset. Okay, let's try the string compression. String compression. All right, it's a run length. Okay. Placing consecutive identical characters repeated 2 or more times with concatenation of the character and the number making the count. To compress AABCC, we do this. Okay, I remember that. Notice that in this problem, we are not adding 1 after a single character. Okay. From a given string and an integer, you need to delete at most k characters from such that the run length encoded version has minimum length. Find the minimum length. Oh, I don't remember. I don't remember. So run length, right? That's simple rule. And we have at most k we can delete. All right. I think I have vague idea of how this one is done. So mostly this is a DP problem, right? So we given an S is A, B, C, D. Okay. So K is equal to 2. So we can delete at most 2. So if it's a DP problem, we have an index and we should have a remain. Right, that's usually how it goes. Index from something to the end. Okay, we have so many remain to remove. Okay, now we say we just need to know from index to the end with this one to remove. So like we'll call dp0k. Right, this is what we want. Then we want to know what is the minimum that we can get. Right, the minimum length. This one shall return the minimum length. Okay, so we go from something towards the end with something to remove. I mean, I can remove myself, right? And if I remove myself, it's just going to be this towards the end. Okay, that's good. If I don't remove myself, then I what, remove, because I remember the ideal is for each one you can do because at the end of the day it's going to be, oh, is this the one that I solved before, right? Yeah, I think I remember at the end of the day the patterns we want is some letter repeated sometimes and some other letter repeated sometimes. And since that is the pattern that we're looking for, the exact letter does not matter, right? The exact letter does not matter. So eventually it's going to be some letter repeated sometimes and some other letter repeated sometimes. So what we're saying is if at a current position, if this is what we want, hey, what is the idea? Most key characters.
Waiting for me for laundry?
No, I'm trying to solve this problem. And I forgot again. It's like the fourth time or the third time I'm trying to solve it. Third time. Damn it. I remember like last week. And this is the problem. I also had 2 comments. I made 2 comments in the forum to help myself understand. And I did both times, and now I forgot again. Man, this is frustrating. How can I remember what I solved in the past? Well, it just means you don't completely understand it, right? That's why you forgot. You're not supposed to memorize this. You're just supposed to understand it, so you can reproduce it later. And I understand the DP setup, but I forgot the actual process of the DP. Like, how do I handle? From this towards the end, what is the smallest, right? And I say, if the current letter is going to be correct, and if I keep it, then what? Dude, I don't remember. I don't remember at all. Alright, no, I don't. I can't. Can't do it. I need to go back to my comments. Is this the one I comment? No. I don't think so. I forgot which one I comment. Alright, let's do this again. Let's go there. Copy it. But hold on, let's see. Encoded length. Okay, I have a function to help me find encoded length. Maybe I can just go through this and I will understand. Yes. if a len s smaller, so we have still something to remove, right? Because it says exactly, we have to remove exactly k, delete at most k, right? If you need to delete at most k, but we don't have anything left, so it returns 0, okay. Try to go through all form to form the first group in the final solution by removing all the letters from index to some I such that the remaining letters are all the same but with different lengths. What the hell does this mean? Removing all the letters from index to some I such that the remaining letters are all the same but with different lengths. From index, okay, it's just, from the current towards the end, and we start to count it, and we start to find the max count. What? And we start to find the max count. So among these letters, we try to find the max count. And then what? To remove equals I minus index plus 1 minus max count. So this is a number to remove. Encoded max count. Hold on, let me think again. So what we're saying is from the current, we're going down and we'll find the max count of something, which doesn't matter. Oh, okay. The thing that does not matter is there will be some letter at this position with some count, right? That's the end, because we are checking at each position, right? At each position, we don't know what it's going to be, but we will encounter the correct letter at the correct position. And then from there, if I go through the whole thing and I just focus on the max count, right? I focus on the max count of some letter. It doesn't really matter. The max count of some, but why it is not just this letter? We can just at each position, we just go down to find the count of this letter, of this particular letter. Why do I use max count? That is an interesting question. To remove, yes, just everything except from the max. Like I don't even consider the current letter, but it feels like if I consider the current letter, it should give me the same idea, the same result, right? Yeah, from this, I just go on. I go on towards the end to count how many of this. You know what? That's actually a good idea. So we avoid this crazy max count stuff. Let's see if it's correct. Not sure. 1531. I don't think I've done 1531. Like, I don't know. Let's go for it. 1531. Nope. I did not do it. It was during a different thing in the past, so it should be 12/27. 12/27, 2023. 12/27. That's not right. It's 2022. What? Dude, 2023 12 challenge 12 20. Oh, it was a really? It was a Java? No, it should be string compression. I don't understand. It was... Alright, can I do a code search? I shall, right? I shall be able to do a code search. Code search. How do I do a code search? Code? No. Can I do a code search? Code search. Fuzzy file. It's not within files. So code search among files. Yes. A telescope. Grab string. Wait, how do I do that? Toggle. Search. Diagnostic files. Grep. Okay, SG on search grep 15 31. No good. It's live grep. I don't know. Help grep string telescope grep string. Parameters options table. Do you have an example? Telescope. Find file. How do you launch live grep? Start typing. Yeah, I'm inside, right? Hold a second. I say search grep. Search select telescope. Search current word. Search resume. Search help. I don't know. It doesn't give me any result. How do you use live grep? See, I don't have this. How did you do this? I have live grep, right? Let me just see the watch one more time. He didn't tell me what key he pressed. Telescope live grep. Okay, telescope live grep. Nope. So I just go live grep. Is that so? We just go live grep. Not an editor command. How to use? Alright, I guess I need to watch some videos on this. But still we have the problem. I don't know where this file is. And it's apparently, I mean, it's Python, right? So it has to be Python. And it has to be that day. Did I not save it? Dude, I think maybe I did not save it. Oh, that would be a major... That would be a major... Okay. Right, that would be a major... How could I not save it? I don't understand. Yeah, 5031 is now there. That's not there. It has to be underscore. 1227. It's all Java. Oh, now I find it. It's here. But that's min cost. Maybe it's 26. 28. Got it. It's 28. There we go. That's still 27. What? What happened? Oh, I opened it and it just take ages to open. Oh. Lord. There we go. Yes. This is the one. Yeah, that's fine. It's just so we'll do one. Okay. Let's try another one. All right, so the idea. Okay, let's see if we can hide everything. Down. Ah, I cannot hide everything. So we'll do the same. Def. What's it called? Encoded lines, right? Encoded length. So basically, encoded length we have L, right? And then we're gonna return. And again, if L is equal to 1, return 1, right? And otherwise, wait, hold on. Why we handle so much? If L is smaller or equal to 1, we should return L. Otherwise, we just, because the 2 is going to be 2, right? 3, oh, it depends, right? It depends, right? So if L is smaller than 10, right? We shall turn 2, because no matter what, the smaller than 10 it repeats, so it would be that and 2, 3, yeah. And if L is smaller, or should be LF. I think LSF is easier. Right, and then here's else, turn 3, because you have 100, but 100 will be different. 100 will be 4. Damn it! Right, so we say L if L smaller than 100 will be 3, and this one is else turn 4. Smaller or equal to 1, return L. Unexpected indentation. L is not defined. Oh, shoot. Sorry. That's L if. Right? I don't know. Good job. 1, 2, 3, 4. Yes. Oh, it took so long to figure this out. Okay, so that's encoded length, and we say RU cache. We already have it. Max size equals none. Right? And then def dp is going to be index and then remain. I don't know what happened. It's just weird. That's a short for integer, right? Okay, if rem is smaller than 0, shall return math.inf. Okay. If len s minus index is smaller than rem, return 0. Right, so this is not enough letters to be removed. I mean, I could have just, I could have do something like this. We can say max equal to, well, cannot be larger than, we can just do 1000. It shall work. So here I can just do max. That, everybody's happy. Okay. So here is What I'm saying is just starting from the current one, we just count, right? From this going down. Every time we do it, we just group this, and go to the next one, we do the same thing. Now we just say for I in range from index towards the end, right? And then we need a count. Say count is 0. We say if count plus equal to si equal to s index, right? And then at each position you try to say, okay, I'm gonna group this and I will return the results. And I say the to remove, right? To remove shall equal to, because I know the count, right? Know the count, so shall equal to a to remove I minus index plus 1, right? That's the total amount, and then minus count. This is the amount to remove, and I do need to have a res. Not really a res. It's to remove. Yeah, res is I want the minimum. Right, so a res equal to max. And then we say minimum. So res shall equal to minimum res and encoded length. Right, encoded length of count. Right, that's encoded length plus dp. I walk all the way to I. Right, I walk all the way to I, and I say to remove is this whole thing. When remove it, just remain this, and then dp should be I plus 1, and the remaining minus to remove. Right, remaining minus, well, remaining that much, but we to remove this much, and then yeah, so we go through the whole thing. Then we find all this, and at the end, I believe we just return res, right? And we're gonna return dp go from 0 all the way to k. I don't think that's the, but we can test it. Hold on. Take a look. Does it make sense? No, it does not. Oh, that's bonkers. It's not right. All right, so let's just do a little comparison. This is a new idea. I need to make sure that we got it right. Okay. Okay. I think the only thing that's not right is the max count, right? But why would it not be right? That's a good question. I think the encoded length was right. Smaller equal to. Okay, that's one issue. Yes, smaller equal to. Try it again. That is the issue. It should be smaller equal to. Should be smaller equal to. No. Because if it's equal to, we have the same. Basically, I didn't have anything for equal. So now this does not require the mind gymnastic. Right? This does not require the mind gymnastic. Alright, I'm gonna write some comments here. So this is another attempt at this problem without the mind gymnastic. That's over. Mind twister. Does not require mind twister. At each position, right? At each position index, we simply assume that it is the correct letter, right? We assume it is the correct letter. Thus, we go from index to the end and count, right? And for each count of letter S index, we try it, right? We try to see if that is correct, the correct letter with the correct count, because we try it. But this avoids the complexity of thinking about grabbing the max count, right? In the max count from index to the end. And it makes the whole thing easier. And in fact, let's just do one more test. Okay? Let's do one more test on this. And if this one passes, then I'm pretty certain this one shall be right. Yep.
Alright.
Wonderful. Ugh! It's not right. Damn. I thought. Oh my, why? Why? Expected is 4. 1, 2, 3, 4. Why is my 5? Alright. It needs more investigation. I do believe this is a better way, and I think it shall be right, but something is preventing me from making it correct. How? Alright, I'm afraid I might make some silly mistake. Let's hope not. What the 1? Yeah. Smaller than 10. Yeah, smaller than 100. Yeah, and turn 4. Yeah, looks good to me. So, count. I just didn't do the max thing, right? Maybe I have to do the mind twister. Alright, I just do a little investigation on this. I did 3. What? encode the length as 1. That would be very silly if that's the result. It shouldn't be. Yeah, it shouldn't be. But, man, we just leave it this. This will be better. Okay. Alright. Oh, this is right. What? What is the difference? Huh? Okay, we start from 0 and 1, right? And then we go from this towards the end, and we count. Okay, count equal to 1. To remove 0 minus 0 is 1, minus 2 remove is 0. Okay, to remove is 0. So we still have 1, and then go this towards the end. That is 2. This towards the end. I never count of removing this. I should remove myself. Okay. Index plus 1 and run minus 1. Remove myself. And then because these are never removing myself. All right. This looks promising. You remove the current, or not remove. Right? Remove the current, or not remove. Right? When not remove the current, or not removing the current letter, right? We need to group together all the letters, all the same letters, all the same letters. All right, come on. Wow. Wow. This is the one. This is the one. Nah, I just also have to remove. Also, at each position, we have to consider removing it. Oh. That was good. See? You don't have to do the mind twister. That's the thing. You don't have to do the mind twister. Oh. Which is very, very important. So, what do you think? Well, simple as that. We move this down the queue and then we'll deal with this again. All right, that'll be it.